All right, so here we are with lesson 13 from Module 5, Grade 6, and our new addition to our formulas that we already know is the formula for the volume of a cube. So we already know length times width times height is one of our formulas for volume, and that applies to all rectangular prisms, right? Which includes cubes, which includes if it's base times height. Anytime there's a rectangular prism, you can use whatever the length is times whatever the width is times whatever the height is, and you will get the volume. Sometimes, however, they go ahead and do the length times the width and give you the area of the base. So this B represents the area of the base, and then you multiply that by the height, which would just layer that base over and over again, stacking it, making cubic units for our third dimension. So this B represents area of base, which is 2 dimensions, length times width. But with a cube, we can simplify it even more. All we need to know for the volume of a cube is the length of one side, right? And so whatever that side length is, we can just cube it. And so s to the third power, or side cubed, is a formula for the volume of a cube. Because to be a cube, which is a special rectangular prism, that is made up of 6 square faces. And that means all sides are the same length and the same area. And so we can just cube the 2 1/4 here. So here we're just doing 9/4 times 9/4 times 9/4. And if you don't know why it's 9/4, pause the video and figure out why. And then we're just doing 9 cubed, right? 9 times 9 is 81, and 81 times 9 is 729. And that's going to be over 4 times 4, which is 16, and 16 times 4 is going to be 64. So now we just simplify and figure out how many 64s can go into 729. And so off to the side, you can see I just did 729 divided by 64, because we've also learned that fractions are division. And I got 11 with a remainder of 25/64, and so I did 11 25/64 centimeters cubed. And so now we know 3 formulas for volume: the typical length times width times height, but we can also have the area of the base times the height, which is the same thing, right? Because it's just length times width, giving you that base. Or for a cube, and for a cube only, we can use whatever the side is cubed, or to the third power, so times itself 3 times. And so now that we know 3 formulas for volume, which hopefully you wrote down in a journal, go ahead and try the problem set, pause the video, work all the questions on a piece of paper or in Notability, whatever app you're using, and then check back with the answers. For me, I don't care if you use a calculator, as long as you can prove in other situations that you can multiply and divide fractions and decimals, because this is about knowing what formula to use and what numbers to use and how to use them. So a calculator would be fine here as well. So go ahead and try it out and then check back with the video. All right, so feel free to pause and take a look at things, but I'll quickly go over my work. So we're using the volume equals base times height, and you may want to make it an uppercase B to show the difference between this being the area of the base of a 3-dimensional figure, which was length times width, versus a lowercase b, which might be just base of a triangle or something like that. Anyway, I'm now going to use that to do the 37ths times 1/3, which is the, so the 37ths is the area of this, which I'm now calling the base. If I were to flip this on its this side, this would be the base, and then this is the height. So I did 37ths times 1/3, which was 30/21, which is 1 9/21, and that can be reduced into 1 3/7 centimeters cubed. So for number 2, I did that over here, and you can see that to determine the volume, if it was quadrupled or multiplied by 4, and that's just if the height is, that would be 1/3 times 1/3, 1/3 times 4, quadrupled, which is 4/3, right? So 1/3 times 4 is 4/3. So then you do 37ths times 4/3, and you end up with 5 5/7, which again is 4 times of our original amount there. So, yeah, that's really what happens is it takes your original 10/7 is the 1 3/7. I multiply that by 4. So if I multiply the height by 4, I then am also doing the volume times 4 because I'm only multiplying that by one other item. So you're really just doing 4 times h times b, which would just give you 4 times of what those two things are. All right, moving down here, number 3, couple things to clarify. So base times height, and then we have double the base times height. We could do double the height times base. It's the same thing because whichever order you decide to, whichever thing you decide to double, it's still going to double the volume. But if you doubled both, right, double the base and double the height, you're quadrupling the volume, right? Because that's 2 times 2 is 4. And so you could do 2b, 2h, or you could do 4bh. That's going to give you the same volume. For a cube, remember, cubes are side cubed, or this number, whatever the length is, times itself times itself. So 16 thirds times 16 thirds times 16 thirds is 496/27, which ends up being 151 19/27 by, if you divide, and then you get your remainder. And so for number 5, there's an A and a B. And this one took a little more time to kind of break down. But I did the 16 thirds, which is the length of a side, and I multiplied it by a half, which is cutting it into 2 pieces, right? Dividing it by 2, because it says are cut in half. And so that gives you 16/6, which in turn actually cuts the volume by an eighth, which leads me to question B, because we're changing one side, we're changing 3 sides. Does that make sense? Because it's a cube. So you're actually doing half of 16 thirds 3 times, which is 1/2 times 1/2 times 1/2, which is actually 1/8 of the volume. So this goes back to volume with fraction units of like when you're putting a 1/2-inch cube inside of a box, you're going to fit 8 of them for every 1 cubic unit because you're doing a half times a half times a half to get your 1/8. And so I wrote that by cutting each side into half, you are cutting the volume into an eighth of it. All right, number 6, we have a rectangular prism, and so to find the volume and complete this table starts with using the 8 for the length, and times 1 times, again, 3 halves, which is 1 1/2, is 24 halves or 12. So then it's just a matter of we are only changing one dimension. We're going to change just the length, this by a half, by a third, by a fourth. Here we're going to double it, triple it, quadruple it. Since we're only changing the one dimension, however we change that dimension, we're therefore going to equally change the volume. So half the length is going to be half the volume because 4 times 1, 4 is half of 8, times 1 times 3 halves is going to be 12/2, which is going to be 6. And so you'll see that connection every single time. And you can work each one of these, or you'll learn that, again, math's about rules, and rules work pretty consistently. That's why they call them properties. So anyway, we're going to do a third of the 12, the original volume, because we're doing a third of 8, and that's going to give us 4 centimeters cubed. A fourth of it will be 3, because that's a fourth of the volume. And then when we double it, the 12 is going to be doubled. When we triple the length, the volume will be tripled. When we quadruple the length, the volume will be quadrupled. And so B, when it was changed by a third, the volume changes by a third. When the length was tripled, the volume was tripled, or times 3. So the conclusion is that the volume changes equally to however the length changes. And number 7, we have a couple sections. I'm going to zoom in just a little bit more here so you can see that, even though it's cutting off some of the problem. And for this problem, we have 2 boxes, A and B, that when added together give you a total of 14.325. And they told us that one of them is 5.61. So we just have to subtract those 2, right? This is the original formula. Whatever A is plus whatever B is gives you the 14.325. And so since we're doing 5.61 plus B, we can subtract and find that B is 8.715 centimeters cubed. Then, if we know that the base of that 8.715 volume is 1.5, which would be multiplied by the height, we can then divide it by the 1.5 to find what the height is, which gives us 5.81 centimeters, and this over here is just chicken scratch to get to this answer. So feel free to pause and take a closer look at that. And there you have lesson 13.